This is a video from section 1.3 in a linear algebra class. Let's take a look at the following definition. For matrices A and B with the same size, we define the sum of A and B as the matrix A plus B such that for every I and j, we have the entry in the ith row, jth column of A plus B is equal to the entry in the ith row, jth column of A plus the entry in the ith row, jth column of B. The difference between matrices A and B is the matrix A minus B, such that for every I and j, we have the entry in the ith row, jth column of A minus B is equal to the entry in the ith row, jth column of A minus the entry in the ith row, jth column of B. Now, please note that A and B must have the same dimension, otherwise we can't look at the difference between A and B. So in other words, we can't subtract those matrices. Just like when we add matrices, they have to have the same dimension. When we subtract matrices, they have to have the same dimension. And let's take a look at the next definition. If A is any matrix and C is any scalar, the matrix CA has the same dimension as A, and for every I and j, we have the entry in the ith row, jth column of CA is equal to the entry in the ith row, jth column of A times C. So in other words, C can be pulled to the outside. All right, let's take a look at this example. Suppose A is the matrix 5, 2, negative 4, negative 3, 1, 7, and B is the matrix negative 2, 4, 5, 1, 9, 4. And what we want to do is we want to find the matrix A plus B. Now, this is equal to, now I'm going to take 5. That's the entry in the first row, first column of A. And I'm going to add the entry in the first row, first column of B. So I'm going to take 5 and I'm going to add negative 2. Now, moving over, I'm going to take 2. This is located in the first row, second column of A, and 4. This entry is located in the first row, second column of B. And I'm going to add those results. So I'm going to take 2 plus 4. And then I'm going to take negative 4 and add 5. So notice I took the entry in the first row, third column of A, and added it to the corresponding entry in the first row, third column of B. So to finish out the first row, I'm going to get negative 4 plus 5. Moving to the second row, I'm going to take negative 3 and I'm going to add 1. So notice that's in the entry in the second row, first column of A plus B. Then I'm going to take 1 plus 9 and then 7 plus 4. And when I simplify this result, I get the following. I get 3, 6, 1, negative 2, 10, 11. And that's how we find A plus B. What if we want A minus B? Now, let's remind ourselves. So I'm going to take the matrix 5, 2, negative 4, negative 3, 1, 7, and then I'm going to subtract the matrix negative 2, 4, 5, 1, 9, 4. So to get the first row, it's going to be the following. I'm going to take 5, and then I'm going to subtract negative 2. And then I'll take 2 and subtract 4. And then I'll take negative 4 and subtract 5. That's the first row. In the second row, I'm going to get negative 3, subtract 1. 1 minus 9, and then 7 minus 4. And then we'll put C on the next page here. And so if I go to simplify A minus B, I get 7, negative 2, negative 9, negative 4, negative 8, and 3. And so that right there is A minus B. So let's take a look at C. On C, we want 4A minus 3B. Now, let's take one at a time. 4A is 4 times the matrix 5, 2, negative 4, negative 3, 1, 7. And so I'm going to take the number 4 and multiply it by every entry inside matrix A. So, in other words, I'm going to get 20, 8, negative 16 for the first row. So if you notice, I took 4 times 5, that's 20. 4 times 2 is 8. 4 times negative 4 is negative 16. Now for the second row, I get negative 12, 4, 28. Now let's take 3B. This is 3 times the matrix. Negative 2, 4, 5, 1, 9, 4. And so when I'm going to take 3 times every entry inside matrix B. Now, when I do that, I get, for the first row, negative 6, 12, 15. That's the first row. The second row is 3, 27, 12. Just like this. Therefore, 4A minus 3B. Now I'm ready to perform this subtraction. I get 20 minus negative 6, right? 8 minus 12, and then negative 16 minus 15. That's the first row. In the second row, we get negative 12 minus 3, 4 minus 27, and then finally 28 minus 12. Like this. So, therefore, 4A minus 3B. We're ready to do this now. In the first row, we get 26, negative 4, negative 31. 26, negative 4, negative 31. In the second row, we get negative 15, negative 23, 16. Negative 15, negative 23, 16. And we could double check, right? Negative 12 minus 3 is negative 15. And then 4 minus 27 is negative 23. And then 28 minus 12 is 16. And that's precisely what we get there. And that's a good stopping point for this video. This is a video from section 1.3, and this video is based off my lecture notes. And that'll conclude this video. All right, thank you.